In lesson 14, we're going to be working with pyramids. So go ahead and look on page 305, take a look at the pyramid given, and decide if either of these two solids has the same volume. So you have some different strategies here that you could have been working with. So remember that we decided that the volume formula is area of the base times the height and then divided by 3 for a prism. So let me write that down. You can write it as 1/3 area of the base times the height. Remember that's also area of the base times the height and then divided by 3. So you could have looked at the area of this base here and saw that it was 20. So then you could have actually calculated the specific volume here. This might have been enough for you to look here and say, well, this one has a base area of 20 since 4 times 5 is 20. So we know they have the same base area. So then you could have been looking at the heights here. So this one is a pyramid going up to a point, and this one is a prism staying uniform. So this 2 is actually 1/3 of 6. So then we already know that this is 1/3 the height. So then we would know that those volumes are the same, because when we take 20 times 6 divided by 3, that's going to be the same as 20 times 2. So maybe you decided that they have the same volume that way. Again, you could have just also straight up calculated it. So for this one, we've got the base is a triangle. So we would be doing 4 times 6, which is 24, and then divided by 2. So we would get 12 for the area of this base. Then this one is a pyramid as well. So when we calculate the volume here, we're going to be doing area of the base times the height, which is 120, and then divided by 3, which gives us 40. So when you do this one, you're just doing area of the base times the height, since it's a 2-based prism. So this volume is 40. So that's the same as that. And then you could have also calculated here for volume was 20 times 6 divided by 3, which also gave you 40. So we find out that all of these actually have the exact same volume. So let's take a look at these 4 solids, and let's calculate the volume of each one and then round your answers to the nearest 10th. So remember, all of these go up to a point. So these are all pyramids or cones. So the volume formula is 1/3 area of the base times the height, which again is also area of the base times the height divided by 3. Okay, whichever one you prefer. Go ahead, calculate each volume, then come back to the video. So for this first pyramid, if we take a look at the base, we see it's a square. So we're going to be doing 2 times 2, which is 4. So then for the volume, we're going to be doing the area of the base 4 times the height 6 divided by 3. So this is going to be 24 divided by 3. So we're going to get 8 cubic feet for the volume. Shape B is a cone. So we've got a circular base. So area formula for that is going to be pi times the radius squared. So the area of the base here is going to be 4 pi. And this wants us nearest 10th. So it actually wants us to calculate. So we'll multiply 4 times pi to get the base area here of 12.566. So then for the volume, and really we don't want to round in the middle here. So we don't necessarily want to use this rounded version. So maybe I'll just leave it off when I do the volume. I'll do area of the base, which is 4 pi, times the height, which is 4.2, and then divide by 3. So type all of that in your calculator at once. So the 4 times pi was that 12.566. times 4.2, and then divide that by 3. And you get the volume here as 17.59 or 17.6 centimeters cubed. Part C has a triangular base. So we're going to be doing base times height divided by 2. So we're getting 6 for the area of the base. So then when we calculate the volume, we'll be doing area of the base, which is 6, times the height, which is 7, divided by 3. So this is 42 divided by 3, which is 14 kilometers cubed. Part D tells us that the height is 12 and that the base area is 32. So we don't need to calculate the base area. We already have it. So now we just need to do base area, which is 32, times the height, which they told us was 12, and then divide by 3. So 32 times 12 is 384, divided by 3 is 128 centimeters cubed. So then in this next one, you have a cone that's pictured. So let's write an expression for the volume of this cone. There's no actual measurements here, so we're just going to use the R and the H. So remember that the volume formula is 1/3 area of the base times the height. So what we can do is plug in for the area of the base. So the base shape is a circle. So the area formula for a circle is pi times the radius squared. And then we still have that times h. So we just plugged in pi r squared for this b. So this would be an expression for this cone's volume. 1/3 pi r squared h. So if we know that the volume of this cone is 16 cubic units, and the radius is 3, what would the height be? So we can go ahead and plug in what we know into the formula. So we know that the volume is 16 pi. So we'll plug that in. And then we know that the radius is 3. So I'll write down the other stuff. We have 1/3 pi, and then now we have the radius squared. So we have 3 squared. And then times h. So I just substituted in what I knew. So now we can simplify. So I'll just rewrite 16 pi equals 1/3 pi times 9 times h. So I just multiplied the r squared. So now if we do 1/3 of 9, okay, so multiplication is commutative, so I can multiply any of these together that I want. So 1/3 of 9 is 3. So 1/3 of 9 is 3. So I have 3 pi times h. So then we'll go ahead and solve for h by dividing by 3 pi to both sides to get that h alone. So this pi will cancel, okay, and then the 3's will cancel. So we'll just get 16 divided by 3 equals h. And you could divide that in your calculator and get that h equals 5.3 repeating. So if it wanted it to the nearest 10th, you could do that. All right, then what is the radius of the cone if we know that the volume is 16, but the height is 3 now? So now it's the height that's 3. So we'll plug in 16 pi for the volume. Okay, and now we have the 1/3 pi. We don't know the radius yet, but we do know that the height is 3. So again, multiplication is commutative. So I'm going to multiply together the 3 and the 1/3. So 1/3 of 3 is 1. So we just get 1 times pi times r squared. So this 1 basically isn't there because 1 times pi is just pi. So now we'll be able to divide both sides by pi to get that r squared by itself. So the pi's will cancel, and we will get 16 equals the radius squared. And then you undo a squared with a square root. And the square root of 16 is 4. So your radius is 4 in this case. All right, then let's look at an application problem here. So if we read through this story, so a caretaker is making an ice sculpture in the shape of a pyramid for a party. The caterer wants to use 12 liters of water, which is about 720 cubic inches. The sculpture must be 15 inches tall, and the caterer needs to decide how large to make the base, which can be any shape. So what is this situation about? So it looks like it's talking about a pyramid. And then it's talking about filling it with some water. Okay. And the base, trying to figure out how big the base of that pyramid could be. Okay. So how big the base of a pyramid can be. Given the volume, right? So given some volume. And the height. So let's take a look and read it again, this time thinking about what numbers might help us in this problem. So caterer is making an ice sculpture in the shape of a pyramid for a party. The caterer wants to use 12 liters of water, which is about 720 cubic inches. The sculpture needs to be 15 inches tall. The caterer needs to decide how large to make the base, which can be any shape. So what numbers are going to be helpful here? So certainly that it needs to be 15 inches tall. Then there's these two numbers that deal with the amount of water. So one of them is useful for us and one of them isn't. So the cubic inches is going to be useful for us because that's a volume measurement. Liters is not going to be helpful for us. Yes, it's a volume measure, but not in the way that we would calculate volume. And so that one's actually just like extraneous numbers or a distractor number that we don't want to use. All right. Then here's the actual question. So again, a caterer is making an ice sculpture in the shape of a pyramid. So we've got a pyramid. The caterer wants to use 12 liters of water, which is 720 cubic inches of volume. The sculpture needs to be 15 inches tall. And the caterer needs to decide how large to make the base, which can be any shape. Okay, but looking at that base. So draw and label the dimensions of two different bases that would work. So go ahead, using those numbers, figure out the dimensions of a base that could work. Again, it can be any shape that you would like. And then you can come back to the video. So you may have just done some guessing and checking with this. Maybe you decided to try to work backwards again like we did last time. So like in the last example. So for this one, you know it's a pyramid. So we've got 1/3 area of the base times the height. And the base is what we're searching for. So we know the volume. So maybe you plugged in 720 as the volume, 1/3 area of the base, and we actually know that the height is 15. So then if you simplify 1/3 and 15, that's 5. So you get 720 equals 5 times the area of the base. So then you'd be able to divide by 5. So 720 divided by 5 to figure out that that base needed to be 144 units squared. for that base area. So remember, this is the area of the base that you're creating. So then you can literally create any base you want as long as it has an area of 144 units. So maybe you created a square. Maybe you noticed that 144 is a perfect square number, so you decided to do a 12 by 12 square. You could have done any rectangle that multiplies to 144. So maybe you divided 144 by 4. So you knew that it was 4 and 36. Or maybe you did 144 divided by 6. So then it would have been a 6 by 24 rectangle. Okay, you could have done quite a few. Maybe you wanted a triangle. So then maybe you did 12 as your base there. Maybe one of yours was 12, but then you know that a triangle is half as much as the rectangle. So you doubled this length so that when you do 12 times 24 divided by 2, it will still give you 144. But various options for this that you could have done as long as the area of your shape that you drew is 144. So once you found a set of dimensions, you could have just kind of manipulated those. So if you wanted, when you'd started with the 12 by 12. So if we started with the 12 by 12, you could have actually increased, like doubled this one. And when you double that one, then you have to divide this one by 2 to kind of stay the same. So double the height and then do half the width so that they still multiply to 144. So that's one way you could have done it. You could have kept going back to the base area, which we knew was 144 by working backwards. And could the base have been a circle? So could the base be a circle? Certainly. Just the area of it would need to be 144. So how could we find the dimensions, which means the radius of this circle? So we would have to think about the area formula for a circle, which is pi times the radius squared equals 144. So we would have needed to solve for the radius by dividing by pi to both sides. So 144 divided by pi would have given us 144 divided by pi would have given us 45.8. So 8366. And then you would have needed to square root to figure out what the radius measure would have been there. And so you would have gotten R as being approximately 6.77, or if you were doing to the nearest tenth, 6.8. But it can be any shape as long as the area of it is 144. So if you know the formula, you can just set it equal to 144 and work your way backwards. All right, so how are the expressions 1/3 base times height and 1/3 pi r squared related? Pi r squared h related? Well, this b is area of the base, and this pi r squared is the area of a circle. So this second expression is just the volume formula, specific volume formula for a cone. How do you find the volume of an oblique cone? So oblique meaning slanted, so very similar, right? So we just need to have the height. So you just need to have the height, which just won't be the segment connecting the apex to the center anymore. Okay, so your height is going to be just how far it is from that apex perpendicular to the ground, but you would still do volume equals area, 1/3 area of the base times the height, that base area being pi r squared in this case. So if we know the volume of a pyramid with a rectangular base is 200 cubic units, could you find the dimensions for a pyramid? So if the volume of a pyramid is 200, could we find a set? Just has to multiply and get us to this 200. So remember, volume formula is 1/3 area of the base times the height. So volume is 200 equals 1/3 area of the base times the height. So we could just multiply by 3 to undo this 1/3, which would give you 600 here equals area of the base times the height. So as long as the area of your base times the height equals 600, you'll be good. So you can pick any measurements you want. So if you wanted the height to be 6, okay, so if this height was 6, we just divide both sides by 6. So 100 would equal the area of your base. And it's a rectangle. So now you just need to say, well, the length could be 10 and the width could be 10. Okay, because 10 times 10 is 100. You could have picked different ones. So you could have done 4 for the length and 25 for the width, because again, that would get you 100. Could have done 5 and 20, whatever you want, as long as those equal 100, since I set my height at 6. Could certainly have set your height at a different number as well. That's just an example. So if you wanted to change this height here, okay, you could put the height at 20 if you wanted. So then you do 600 divided by 20. So if you were doing this one, then your base would have to be 30. So if your height is 20, then your base area would need to be 30. So your length and width just need to multiply to 30. So you could do 6 and 5. You could have done 3 and 10. Okay, so all of these need to multiply together. So area of the base times the height divided by 3 needs to equal 200. So these all multiply to 600 divided by 3 or times by that 1/3 would give you the 200. All right, so the summary is on page 308. So we can work backwards to find possible dimensions of a cone or a pyramid. Remember that for a cone, the area of the base is pi r squared. So you could plug that in for the b and then work your way backwards. So if we knew a height, we could divide the volume by that height, timesing it by 3 to get rid of that third. And then if we did the square root, we could use that as the radius. But working your way backwards to figure out the volume. And then make sure you just plug it back into the volume formula to make sure that it works.